most of us in here are old enough that when we did the research, we worked on refined, bleached, deodorized oil. You look out the old work of soybean oil, it was pure good oil, good stuff. But we have what I'll call fractionated products or byproducts from the oil processing industry. On the left, it's not a real clear picture, is a rough outline of soybean oil processing where you can bleach it, degum it, etc. You'll get the RBD soybean oil that you'd buy in the store. You'd end up with oil soap stock that can be acidulated, and you can end up with soy acid oil. Soy acid oil having 90% fat, 55% free fatty acids. So there's a product, high free fatty acids, that not necessarily is a rancid product. That's why I get into this. Free fatty acids and rancidity are not the same topic. And you can get those products blended with veggie oil or packer grease for blended fat. So there's what I'll call a fractionated type product or a new product, so to speak. You can get the same thing in palm milling. You take the palm fruit bunch, you get the palm fruit, you mill that or you process that, you can get the palm oil or you can get the palm kernel oil. Those oils can be further fractionated. If you look at your cosmetics and things, your shampoos and things like that, you'll see a lot of different fatty acids in there. You can get a lot of different fractionated products. So I had interest in that relative to a free-flowing dry fat. Any of us old enough remember Fat Pack 100? Free-flowing dry fat. Do a search on Journal of Animal Science on that sometime, of how many thousands of hits you'll get. We used to add it all the time. My question was, what is the energy value in some of these fractionated products? So the top one here, I had a colleague call me. We can get just tons and tons of this fractionated bulk, not hydrogenized palm stearin. It's a nice free-flowing little beadlet. What's the energy value in that? I go, well, I can slap it on the equation, I can give you a number, but I have no empirical data. Now, likewise, for some of us, or some of those, you're used to more of some of your dairy industry, you can have a free fatty acid product. So here's a product, 100% free fatty acids. It's largely palmitic acid. So two different types of products here. What's the energy value in that? And likewise, what I have was a colleague of mine who had from the food industry, I called it a fractionated monodiemulsifier. What's the energy value in that? Let me set up the slide a bit here. The blue is the gross energy of the product. The light pink is the predicted value based upon the Weismann equation. The red is what we actually determined of the energy value on that. So here's a monodiemulsified product. It's basically 96% of these two fatty acids. This is a lipid now. Here's a fractionated saturated animal fat. Again, 16-18-0. And here's a product more palm-based, fractionated palm oil with lecithin of that. So when we did this study, predicted would be about 7,000 per kilo, and it's actually about 3,000. Now I remember when we were doing this study, again, I need reading glasses, collecting pigs. These are nursery pigs, young pigs, and there appeared to be a little white pellets in their feces. But you collect and you move on with life. My technician comes in. She goes, I can't dry the feces of these pigs. You can always dry feces of the pigs. She goes, no, I can't dry them. They won't dry. And she goes, oh, by the way, and she's wearing those purple latex gloves. She goes, grease smears on them. No way. Well, basically the fat was passing right through them. So you're having very poor digestibility of some of these fractionated products, yet predicted they'd be pretty good.